Okay, hi Laura. I think you wanted me to do part B on this, so you're fine on part A and part B you're confused about. I'm not surprised actually, because this is like the opposite. Well, it's very much related to finding turning points, yeah? Now, when we find turning points, we normally find where dy by dx is 0, because there the gradient will be flat. But if, like we've got on this question, we've got to find where the gradient is infinitely steep. Well, you've got to think, how do I get infinite steepness out of this equation here? Well, you get infinite steepness, you get infinity, loosely speaking, when you divide by 0. Think about 0 divided by 0.1 is 60. 0 divided by 0.01 is 600. 0 divided by, 6 divided by 0.1 is 60. 6 divided by 0.01 is 600. 6 divided by 0.01 is 6,000. You can see, as we're getting closer to 0 on the bottom, we're getting larger and larger and larger. And so you actually get infinitely steep points on a curve when you're dividing by 0. And that's what's so hard about this question here. We need 3y minus x to be equal to 0 because we want the denominator to equal 0. And in that case, y is x over 3, or x is 3y. It's probably easier to use x is 3y actually. Now, I still haven't finished it because to find the exact coordinates of P, I'm now going to have to plug that back into the original equation. Because what that's telling me is that, and you can kind of see it on the diagram, the points P and Q will lie on the line y equals a third x. And so we're now going to find where y equals a third x hits this funny looking curve up here. So let's finish it off. I'm just going to plug that in, that expression x equals 3y in here. So if x is 3y, then I'll actually have 3y all squared minus 2 times x times, minus 2 times 3y times by y plus 3y squared, and that should equal 50. And so that's going to give me 9y squared minus 6y squared plus 3y squared equals 50. So that's going to be 6y squared equals 50. And so I guess y is the square root of 25 over 3 plus or minus, which is, I suppose, roughly, what is that, like square root of 8 and a third. I'm just trying to think roughly what it is, because I'll put this up on GeoGebra in a second and we'll see if I'm right. Once you've got y, you still need to find x, but we just need to times that by 3 to find x. And so x is going to be plus or minus 3 root 25 over 3. And that is the exact, oh, sorry, they wanted p, did they? P is on when it's negative, yeah? And so to find P, I need the negative y and the negative x one. So for P, the coordinates are going to be negative 3 root 25 over 3, and then negative root 25 over 3. And that should be right. Explain briefly how you'd find the coordinates of the point that is furthest north. Well, there I'd make y minus x equal to 0 because dy by dx would equal 0, in which case the top is 0. So that's the more familiar case, actually. That's the one which is probably slightly easier. Now, just to check I'm right, if I can just, I'm just going to quickly basically use GeoGebra online. Am I taking, yeah, this should work. GeoGebra. If we just type in now the equation of the curve, what was it? X squared minus 2xy Ollie, leave the tortoise alone, Ollie. Ollie, it's not done anything to you. Don't you hurt that tortoise. You leave Sally alone. Right, sorry about that. Plus 3y squared equals 50. Uh, oh, plus 3y squared equals 50. Ollie, come back. Did I? Equals 50. Right, why is it not drawing that graph? Is it just... that hasn't worked out very well. I think it's because I was distracted because my son was tormenting the... Sort him out, Isabel. Minus 2xy plus 3y squared equals 50. Let's see if it works this time. There we go. I don't know why it didn't work last time. Now, we said it was roughly, if we just go back to our answers, this is just my way of checking because I haven't got the mark schemes or anything, but I do like to check things. So if I type on my calculator, root 25 over 3, that comes to 2.89 basically, times it by 3, you get 8.66. So let's have a look. Minus 8.66 looks right, and minus 2.89 also looks right for that turning point. So yeah, looks like we got it right. Hope that makes sense, Laura. All the best and keep up the great work. Well done. Bye bye.